Hello everyone, welcome to my channel. In this video, I would like to talk about my experience as a modern day software engineer. I want to go through what you should expect as you join a modern day software company and also highlight some of the skills that you should be familiar with. This video is intended for someone who's from a more academic background, and by academic, I'm referring to both traditional computer science schools and universities, as well as boot camps and other self-taught individuals. So let's have a look at this diagram. I actually drew this myself because I was presented with similar diagrams when I was studying computer software, and usually this is the diagram that they'll present you with, and I can only say that this is very outdated. They're still talking about HTML and CSS as when they're referring to user interface, and it's from ResearchGate, so you can tell it's a little bit outdated. Probably this diagram is talking about the 90s, maybe even the early 2000s. So this is from my professional working experience as a software engineer, and I'll be going over each component one by one. So let's start with the physical layer, and I just have a giant component named hardware, and in the modern day context, this is usually referring to data centers. And if you apply for a job as a software engineer, chances are you will not be working directly with hardware. And if you do, you are working for a very specialized hardware company. So I will just skip over this component. And next up, we are on to infrastructure. In most modern day software companies, infrastructure is an entire team that usually works with these technologies. Continuous integration, that's CI, continuous deployment, that is CD, databases, containers, virtual machines, clusters. When you're working with clusters, usually we're talking about Kubernetes and also Amazon Web Services or the Google Cloud Platform. For the most part, you're concerned with scaling at most modern day software companies. CI/CD, so continuous deployment. Like, think about how a company with hundreds, if not thousands, of engineers would operate, right? Everybody's trying to fix their bugs, release their features. How do you make sure that you are provisioning auto updates? And if something goes wrong, how do you roll back? How do you do damage control, incident response? For the most part, my involvement with this would be testing requirements. So that's unit testing, end-to-end testing, and also scaling, usually for engineers who are not infrastructure engineers. sometimes you'll manually scale the number of containers to solve some of the performance issues that you experience. So on to the database. If you work for a very large company, you will probably have multiple teams dedicated to databases. I personally have involvement with patching, backfilling data, migration from one database to another database, as well as a schema update. So we maintain the old one, but we are changing how we store certain things moving forward. And now on to the platform. In my opinion, most of the curriculums around computer science happens at the platform layer, and specifically these two. So by app, I'm referring to all the backend logic, so things like Python programming, Golang programming, and also sometimes compile or transpile into front-end code. And now on to data transformation. Data transformation. So if we look at the diagram, the data transformation, it mostly directly interfaces with the database component. And this could be, for example, when I was working on a project, we had a data transformation job that sits in the platform layer, which regularly obfuscates users' private and identifiable information. And on to monitoring, and I think this is actually the most interesting part, because think about your most basic computer science courses and even some modern day YouTube tutorials. Usually, if not always, I would bet 99.9% are teaching you to debug using essentially print statements. And when you work at a real company that has a business and also probably have more than one engineer, how would you verify with print statements that only you can see on your personal laptop? So that's where monitoring comes in. So this is an example of a modern monitoring solution by Grafana. It's an open source solution. Essentially, you can think about this like your print statements, and it records errors, informations, and tracing of how your program executes. You can also attach the JSON if it's an API response. You can dedupe, you can order it by the time you receive those logs. You can also build custom metrics around these logs that you ingest. Another good provider of this monitoring service is Datadog. this is again directly from their official website. I would be quite surprised if any academic institution actually incorporates this in their teaching. Again, it's not hard to learn, but it takes some getting used to for someone who is a new grad. And now on to the product layer. Obviously, we have the web user interface, and I have personally worked with React and Angular in both JavaScript and TypeScript. And like I mentioned previously, you can do something called transpiling. So this is the official definition. This is a process of converting web code, typically modern JavaScript, into a format that can be executed by native mobile platforms. So this is a way for some companies to release mobile apps with Android and iOS. Some companies will also have a team of native iOS, so that's Swift, and Android, which is Java and Kotlin, in addition to the front-end engineers specializing in web. And iOS and Android, they have their own flavor of and their own quirks. So for example, a website, if you release a new feature, you're not governed by some marketplace, whereas iOS and Android, respectively, they're governed by Apple's App Store and Google's Google App Store, Google Play Store. So when you want to upgrade your feature or you want to release a completely new app, you need to get approval with iOS and Android. And I believe there is a schedule. They don't respond to you right away. These are the things that a mobile engineer would be more familiar with. I had encountered some review issues with Apple Store when I was working on probably the only mobile project that I was involved with. Fun memories for sure. And I put other operating systems here because maybe you are working on a desktop app for MacBook, or maybe if you work for a more hardware focused company, perhaps there is some other operating system that I am not covering. And finally, the A/B testing. I decided to leave it here because this requires user interactions. And for example, you can release only, let's say, 10% of users version 1.0, and you release you keep the rest 90% at version 0.9, and you verify that 1.0 is working and enhances the user experience, and then you release to the rest 90%. And this release process can be done gradually as well. And many big companies often have their own infrastructure to manage the gradual release that I just talked about. And in terms of releasing, there is also usually and there are also some infrastructure that supports further customization using configurations. So for example, that would be internationalization. So those you have the same web user interface, you just to fill in different names for a different region or language. So what you do is you at runtime you plug in uh, all the variable names, and then you release it to different app stores in different countries. And at the application level, this A/B testing also directly converses with the platform's experiment. And under experiment, you could be a fully research-oriented person working on the latest machine learning models or data science experiments. And finally, I want to discuss security, and I left it over here. And this, the shape of this block indicates that this spans all the layers from the physical hardware layer all the way up to the products and application layer. For the most part, if you are a full stack developer, you need to be aware to not release or record any API credentials, tokens such as SSO tokens, and other confidential data such as the user password in plain text. Every company has security teams that would provide you a very strict process, sometimes a custom built internal platform for you to either verify these credentials or to make updates to these credentials. It's called a rotation. And in some very rare cases, you might need to view them in plain text. And for that, every company has a slightly different protocol, but you need to make sure you have a process that you have obtained approval from security to do that. So this concludes my tutorial on the modern software engineer. Thanks for watching.